that's pretty much about how those things look, these structures. So then what we can do from there, we can now group the synovial joints, all those movable joints, into different looking structures according to how they look, and classify them. Because the way that they look, the shape, will dictate what they can do. And so we are interested in understanding of what kind of ranges of motions will these joints give us. So look at that. We have a ball and socket, a condyloid, a hinge, a pivot, a saddle, and a plane joint. They all kind of look in here the way that we have. So let's go through them briefly. So the ball and socket joint is a simple one. We have a ball-shaped head and a corresponding concave socket that allows movement in all directions. So for example, you feel your hip bone, your thigh bone going into the hip. So there's a very round head that feeds right into that hip bone. Let's see if we see that here. That's this one right here. See that round structure here, and then this part here, that's the hip bone. So it's right in here. So that joint allows us free movement in all directions. That's pretty good. The shoulder joint is similar to that. Then we got the condyloid joint, and that's an oval-shaped head with a socket that allows movement in two main directions. They're right here. Mainly the wrist joints are like that. Because the wrist joints, you don't really can turn it that easily around in circles, it crackles and stuff. But you can go up, you can bend it in forward and backwards and sideways. You could do that. So that's a condyloid joint. And then we have a hinge joint. And a hinge joint is a cylindrical bone fits into a gutter-like depression of another bone. And so we move in one axis. So for example, the elbow, where the elbow, the forearm, one of the main forearm bones that grabs the elbow bone, the upper arm bone, by bone wrapping around the upper arm bone. And that's that gutter-like depression of that other bone. We can see that right here in the elbow that closes and opens. It's not that good of a picture, unfortunately. Sorry about that. But that brings us to the next one. That's the pivot joint. And that's a bone end protrudes into a sleeve or a ring of composed bone of another bone. So again, we move around one axis. And so that's like, for example, what we just talked about before in the axial skeleton chapter. The ends of the axis sticks up through the ring of the atlas, and the atlas rotates around the dens. That's your classic pivot joint. We also have this in the radio-ulnar joint. And then the saddle joints is when two, that's kind of weird looking thing, two concave surfaces create two main movements. We have that, for example, in the first metacarpal and trapezium joints, which is right here in the wrist. See right here in the wrist, that's a thumb right here. And then the thumb is one of these things, and the next one, the trapezium, that's bone called trapezium, is the other one. And so they move this way or this way, but not in circles. So it's kind of goofy that way. Okay, so joint mechanics. This part talks about the directions the joint can move is determined by the shape of the joint, as well as the arrangement of muscles and ligaments. So we look at joint movement. We have basically three main axes, and we move around the three main axes. And so that gives us different types of movements. Gives us the main movements of flexion and extension. Flexion is, for example, you take an elbow and you bend it. It's decreasing the angle of a joint. That's flexion. Extension is when we increase the angle of a joint. For example, here in the knee, we close in the angle. That's flexion. We bring it back out and extend it and straighten out the leg. We also have the shoulder. This is the shoulder, so that's a little goofy. So you're looking at the head and the shoulder. Moving them up decreases this angle right here. Moving them down extends it and it increases the angle. In the shoulder, we can also go hyper. We can go beyond the normal. And that's called hyper extension. The neck, we got this like that. Chin to the chest is flexion. Bringing it, looking upward is extension. Then we got abduction and adduction. And those are weird because we have both the same word except for one letter different. So we got an A-B adduction, and that describes moving a limb away from the midline. Okay. And then we got a deduction, that means moving the limb back to the midline. So let's look at these. Over here. A B-duction moves it away, a deduction moves it back towards. So I always remember that a deduction is like adding a limb back to the body. So if the hand is out here, I want to add it back to the body, bring the hand close, that is a deduction. And a B-duction is when it goes to the opposite direction. Okay. And then on the arm, I can basically do another movement where I can move the arm in a sort of cone-shaped circle. That's called circumduction. And then here we go, internal and or medial or inner rotation versus external, lateral, and outer rotation. So that moves a bone around the longitudinal axis. And so let's look at what we got here. Yeah, so we got a rotation of the head. We can already rotate it. We can also rotate the trunk, but then we also can rotate the leg. We can rotate it outward, and that's lateral, or we can rotate it back inward, and that's medial rotation. And then we got some specialized functions. So we got some movements, for example, the one movement here, the pronation and supination, has only to do with the wrist. So supination is when we bring the palm upwards, like in bringing a bowl of soup, holding it upward. That's supination. Pronation is when we pronate, when we bring the palm downward. And so that motion happens in the forearm, in the wrist. And then the other motion that we have is down at the ankle. We have a couple of them. We have dorsiflexion and plantar flexion. But we also have inversion and eversion. So dorsiflexion is toes up. The dorsum of your foot is the top portion of your foot. And then plantar flexion, that's kind of easy. Plant your foot into the ground is plantar flexion. So plants go down, dorsum goes up. And then this eversion and inversion is weird. But the foot does also move sideways a little bit, sliding in an angle. So when you bring the toe in and scoop it sort of inward up, that's inversion. So that's often how we can sprain an ankle. It's an inversion sprain. And then the opposite motion as the pinky toe moves out as well as possible and up, that will be eversion. And then the last movement is one that we have in the hand, which is actually crucial for us being who we are, and that's opposition. The fact that we can oppose our thumb to the fingers makes us be able to grab things and manipulate tools like no other animals in the kingdom can. So that's pretty neat. Alright, so those are sort of the joint things I like you to have an understanding of, and I hope you have. I know it's a lot of terms, so don't go too crazy in terms of getting confused memorizing all that.